So in the last video, we discussed how data travels from RTU to National Load Dispatch Center via sub LDC, then SLDC and RLDC. So in this video, we'll first try to understand various roles and responsibilities of NLDC, RLDC and SLDC, and then we will proceed forward. So let's first understand the role of National Load Dispatch Center. So the role of National Load Dispatch Center is monitoring the operations of national grid. It also ensures the grid security. It also restores the synchronous operation of the national grid. So before 2014, we were having southern grid not integrated with the rest of the grid. That's why we were having different frequencies in India. When we integrated the southern grid also with the rest of the grid, now we have one nation, one grid policy, where all across India we have single frequency. So in this case, the role of NLDC is important to ensure the synchronous operation of the power system network of India. Now it also ensures the efficiency and economy of the national grid. It also ensures the monitoring and optimal operation of transnational exchange of power, because we have power exchange among our neighboring countries, say Bhutan and Bangladesh. So when we exchange power among our neighboring countries, we have to make sure that the required power is being exchanged. So monitoring and energy auditing for transnational power corridor is being taken care by National Load Dispatch Center. It also responsible for dissemination of information to the regional load dispatch center, because it monitors and supervises the operation of regional load dispatch center also. At the same time, it also levies the collection of charges and fees as instructed by the CERC. CERC is nothing but Central Electricity Regulatory Commission. So now, how energy accounting is done at NLDC level? So for energy accounting, it supervises and controls the transnational links. It also supervises and controls the regional links, that is the link between various regions with the help of RLDC. So it supervises the activities of RLDC and coordinates for the inter-regional power exchanges for energy accounting. It also coordinates for regional outage plans with the help of regional power committees. So if we have any scheduled maintenance plan in a particular corridor, the NLDC will coordinate with RPC to execute that plan. Now let's try to understand the role of RLDC. RLDC works under the supervision of National Load Dispatch Center. It is an apex body for integrated operations in a particular region. Say in India we have 5 RLDCs, north, east, west, south and northeast. And in Northern Regional Load Dispatch Center, we have 8 states involved in that. So we have 8 SLDCs which are being supervised and controlled by Northern Regional Load Dispatch Center. So basically it is also a nodal agency for short-term open access. It ensures the compliances for the licensees, generating companies, the generating substations or the generating stations, or any other person concerned for power transmission in that region. What are the various roles or functions of RLDC? It ensures the optimal scheduling and dispatch of electricity, monitoring of grid operations, exercise supervision and control of ISTS, that is interstate transmission system. So it ensures the power exchange between states, keeping accounts of electricity transmitted, and ensures the real-time operations of the power system network in that region. It also supervises the SLDC which are in a particular state. Now, what is the role of State Load Dispatch Center? So, State Load Dispatch Center is apex body in a state. It works under the direction of RLDC. The role of SLDC is the optimal scheduling and dispatch of power plants, monitor the grid operations, keeping accounts of electricity transmitted. Other activities like real-time operations it has to ensure, and exercise supervision and control of the power system network under that particular SLDC. It also ensures the supervision and control of various entities such as licensees, the generating companies, generating stations, substation, and any other concerned entity which is responsible for power transmission in a state. So this is the role of SLDC. Now let's first try to understand the flow of data in SCADA as well as the associated applications such as energy management system. So energy management system is one of the most important application which runs based on the SCADA data for better monitoring and control of the transmission system. So let's first understand how it works and how the SCADA data is utilized. So first, the data is processed by RTU from the field, and then RTU sends data to SCADA, that is supervisory control and data acquisition system. At SCADA application, the data is filtered, and if there is a missing data, it is replaced with either forecasted or previous data, or it is calculated with the help of power balance equations. So SCADA data is basically a refined data set after the data which we receive from RTU. Now this data is ready to be processed by various energy management system application. So whatever we see below the SCADA layer is the part of energy management system applications. Now let's see how the data is being consumed by various applications. So first application which will receive data from SCADA is state estimator. It will first process the topology of the power system network. Then this topology will be shared with the state estimator application. State estimator will execute and find out the voltage magnitude and voltage angle at all the buses of the power system network. And then when we get the state estimator results, basically the voltage magnitude and angle, based on that data we can calculate the power flow among various branches of the power system network. So now based on the state estimator results, we can compute all the required parameters such as power flow or the current flow at various branches and so on. Now this data we will use for further processing. So we have now the current network solution as an output of state estimator. These state estimator results will be shared with the forecasting application. At the same time, these informations will be stored in a historical database for any post-mortem analysis. Now the forecasting application will take input from historical database as well as it will take input from weather as well as the future growth forecast inputs. Then it will process the data and forecast the future values of power flows in the various transmission lines. This will help in carrying out the generation planning as well as expansion of the power corridors. This forecasting information will be utilized by power flow to run the postulated network solution. This postulated network solution will be processed by the network analysis application, which runs mainly the short circuit analysis and contingency analysis. So with the help of short circuit and contingency analysis, the information of the security of the power system network will be achieved. We will know that how the system will behave when there is a contingency in the system. So we will prepare ourselves for those contingency for continuous operation of the power system network, and based on those inputs, that is postulated network solution as well as the current network solution, we will try to optimize the power system network in the terms of improving the security or enhancing the security level of the system. And then this information will go to automatic generation control. In addition to that, the economic dispatch will also be an input to automatic generation control, as well as whatever the generation scheduling we have, that will also act as an input for automatic generation control, which will set the valve opening of the various generating stations for balancing the demand supply equations. So this is how the energy management system application works using the data received from SCADA. Now there are certain challenges in the SCADA system which we have right now. Let's try to understand what are those challenges. The first challenge is slow data reporting rate. The data which we receive from RTU is reported at the control center at the rate of, say, every 5 seconds, which is very slow. As we discussed in previous video, that the power system collapsed in July 2012 within 3.5 seconds. So even if we report the data from RTU after every 5 seconds, we will not be able to do fast calculation, and we will not be able to visualize the system almost in real time and save our system from any possible blackouts. So this is one of the major challenge which we have in the SCADA system. Mostly the SCADA system is centralized. It works mainly on client server architecture, which is basically the old IT architecture, and data is aggregated at the server level and information is processed at the centralized location. This itself will create a lot of delays in the data reporting because of following the hierarchical data reporting structure. It is also incapable of large data handling because the system is not designed for very large data processing capabilities. Being a legacy system, we do not have a capability to process big data or large size of data in the SCADA system. Mostly the SCADA system is operator driven. Operator has to keep on seeing the single line diagram on SCADA display to see any abnormal or any contingent situation in the power system network. So there is less automation capability in the SCADA system. Most of the things are being driven by the operator. Further, the SCADA system has security issues because the SCADA system was developed in late 80s, which is where we are using right now. So at that time we were not having any concept of cyber security or power system data communication related security aspect. So because of that, we have inherent security issues in the SCADA system which we need to address. Legacy protocol is another challenge because the protocol was developed when we were having the serial data communication, and from that point onwards the communication network and the IT system has evolved a lot, and there is a need to change the legacy protocols to adopt the new SCADA protocols. Data interoperability is another challenge. Being a OT application, the data cannot be easily transmitted from OT to information technology application. So that also needs to be addressed when we talk about the SCADA data interoperability. New technology integration has its own limitations. Say, for example, if we want to integrate the data received from phaser measurement unit, the SCADA system is not capable enough to handle that fast data reporting. So integrating new technology in the SCADA system is another challenge which needs to be addressed. We have limited dynamicity in the SCADA system because it is not flexible enough to add any new feature or function in the SCADA system, because it is not based on any dynamic architecture of the information technology. It doesn't have any openness of environment. That means that we cannot deploy that SCADA system on any software environment. We have to take care of a lot of operation technology related limitations. That's why the system is not flexible as per the latest IT trends which we have in our information technology space. Limited complexity handling. The complexity process are not basically designed in the SCADA. So if we have some complex scenario, the SCADA system will not be able to address that scenario, and then this has to be addressed by the operators manually. So this also has another limitation which we have in the SCADA system. Then it is not a robust solution because it is very vulnerable to cyber attacks. It is not as per the latest IT architectures. So therefore it is not suitable to be deployed at latest IT framework. So because of that, the SCADA system needs to be modified or redesigned to address the new needs which we are seeing in the smart grid technology.